the previous video, we 3D printed the moon component of the lamp. In this video, I want to focus on the electronics. We're going to be using an ESP32 as the brains of the project. This will let us control the lamp over Wi-Fi. For the light, I've got a 3-watt common anode RGB LED. Now, a common anode RGB LED has a circuit diagram that looks like this. Now we'll need to add current limit resistors. These will need to be at least 1 watt resistors, as they'll be dissipating quite a large load. To provide a control over the brightness of the different colours, we're going to use pulse width modulation. So with pulse width modulation, a square wave is generated by the ESP32 and the duty cycle of the wave determines the brightness. So if we have a 50% duty cycle, we would get 50% brightness. And if we had a 10% duty cycle, we would get 10% of the brightness. And similarly, a 90% duty cycle would give us 90% brightness. Now, we can't switch our LEDs directly, as it would be far too much current for the ESP32 to handle. So we'll use N-channel MOSFETs to switch our LEDs. In order to ensure the MOSFET turns on completely, we'll pull the gate up to 5 volts and run our ESP32 in open drain mode. Open drain mode means that our output acts rather like a switch to ground. When the output is low, we are connected to ground. And when the output is high, we are floating. This means that we can safely pull up to 5 volts without damaging our 3.3 volt device. Now, I'm going to forego a gate resistor, as our circuit is not going to be switching at high speed and we're not dealing with very high currents or voltages. So we just need to make sure our pull-up resistor is low enough to switch on the gate quickly, but not so low that the ESP32 has to sink too much current. I'm going to go with a 470 ohm resistor for this. This will give us around 10 milliamps flowing through the ESP32, which is well within its capabilities. So let's test our circuit on a breadboard to make sure our assumptions are all correct. So I have our components. We have an ESP32, a power MOSFET, a 470 ohm resistor, a 1 watt 5 ohm resistor, and a 3 watt LED. So let's assemble our circuit. that's our circuit complete. I've wired up the blue channel and loaded my prototype software onto the ESP. Let's see if it works. So that's driving the blue LED at a 100% duty cycle. This is around 50%, 10%, and 0. So our circuit should work nicely. In the next video, we'll jump into Easy EDA and build a complete schematic and circuit board. So, see you in the next video.